problems that we did by guessing and checking and by using the graphing calculator to see points of intersection, we can actually solve, but we have to talk about logarithms in order to do that. So today and tomorrow we're going to kind of talk about what is a logarithm, how do we evaluate them, how do we graph them, and then kind of the next few sections after that are going to be spent on properties and how do we solve equations with them. And as we go through this stuff, I'll try to give you ideas of calculator, no calculator stuff, because when we get into logarithms, that's really where we're going to talk a lot about no calculator, but then also the calculator is really great because we can approximate values using logarithms, doing stuff that they've been doing for hundreds of years, but now that we have calculators, we can do them like in an instant. So this first page here is just to remind you, why do we have logarithms? Well, every operation that we do, we have inverse operations to undo it, right? So these are my lovely symbols here, right? For addition, we know that if we're solving an equation with an addition in it, what do we do to get rid of addition? Subtraction. Monday morning interactive stuff here. And for multiplication, what do we do to get rid of multiplication? Division. Again, I wrote x squared because I'm going to write it. When we have powers, right? And so I just did x squared there. What do we do to get rid of a squared on x squared? We square root it. And we can do the same thing for cubed power. We can cube root it. Fifth power, we can fifth root it. And when you have exponential functions, like 2 to the x power, to get rid of that, you can do a logarithm. So the inverse of an exponential function is a logarithmic function. Logarithmic. There's an extra a there, right? All right, so really important that we understand the definition of it, and really important that we understand like the restrictions on it as we do it, okay? So, if x is greater than 0, and a is greater than 0 but not equal to 1, right, then we can say the equation y equals log a of x, if and only if, I didn't put any magic here, a to the y equals x. Is that true? Really, really important without a calculator that you know this equation here, that you know how it changes from a logarithmic equation to an exponential equation. So I always remember, like when we say this, we say y equals log base a of x. So a is the base. A is the base over here, right? So that makes sense? The x value is what you get when you take it to a power. So the x is your answer, and the y is the exponent. And so the big thing I want you to get is a logarithm is really just an exponent. Like the answer to a logarithmic problem, the y value is just an exponent. A logarithm is just an exponent. So when I say evaluate this, I know, okay, so on my calculators, they don't do log base 2. But on newer calculators, a lot of the scientific ones, maybe some really nice new graphing calculator ones, they do log base 2. But on questions like this would be without a calculator. Because I want to know, do you know what it means to find the answer to a logarithmic problem? And you can always use this to help you. So we'll kind of do a few of these, and then we'll talk about how if you just remember the answer is the exponent, you maybe don't even have to do any work to do these, right? So f of x is the same as y. Log base 2 of 64. If we rewrite it, this is your base, so 2 is the base. The exponent is what we're looking for. So we could put y there, we could put f of x. You could just leave a blank there, question mark, equals x is your answer. So this is just saying 2 to the what equals 64. And yes, I could give you some like this, and I'd expect that you could work it out. If you don't know what 2 to the what equals 64, that you could work out without a calculator, how many times do you multiply 2 together to get 64? And the answer is, it's a lot of math on a Monday morning, right? I always know 2 to the 5th. Maybe I'm just a weirdo that I know 2 to the 5th is 32. So, so to me, I know it's 6. But if you don't know, right, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That looks like divided by. Times 2 is 64. So how many 2's did you multiply together? 1, 2, 3, 4, 5, 6. So the reason I say a logarithm is an exponent is because the answer to this is just the exponent that makes that true. 2 to the what equals 64? 6 is the answer. Memories of this from last year? So what's this one saying? Here's my base. Here's my answer. What's the exponent? 7, I like to do this. 7 to the y equals 1. Right? The base, the answer, I'm trying to find the exponent. What exponent gives me a value of 1? 0. So the answer here is just 0. So no calculator, you don't have to show work on that, right? If you can just work it out. But if you need to show work, that's the exponential part. You can just say 0. I mean, you can say if x equals 0 if you want. Right? But the answer is just that exponent. Okay? Oh, let's get trickier. What about this one? 10 to the what equals 1 over 100. How's your negative 2? Because you just know. Right, like you could always say like you want to write them as the same base if you don't know. So you could write 100 as 10 squared, right? And then you could bring that up and make it a negative, which means that it's just 10 to the negative 2. 10 to the what equals 10 to the negative 2. Oh, it's just negative 2. If your base is not a fraction and your answer is a fraction, you're going to have a negative exponent because that's the way we move things from fraction form. Lots of people get in a hurry on these because they aren't that bad to do, and then they tell me 2 is the answer to number 4. That's not right because this would say 25 to the what equals 5. Right, so 25 squared doesn't equal 5, but how can you relate 25 to 5? What do you know? If I said 25 is what to 5, what would you say? Forget about the exponent for a minute. Just how could you relate those two to each other? What could you do to 25 to get 5 out of it? Divide, yeah, that's true, but that doesn't help me with an exponent. What else could I do? What could I do to 25? Oh, I could square root it, right? The square root of 25 gives me 5. Can we write square roots as exponents? Yes. So if you have a square root or a cube root or any kind of root, what kind of exponent are you going to have over here? A fractional exponent, right? So this is 1/2. And you can check on your calculator, right? A square root is the same as a 1/2 power. A cube root is the same as 1/3 power. So all those things from algebra 2 kind of come back to us. So big things I want you to recognize, if the base is a number that's not a fraction and your answer is a fraction, you're probably going to have a negative exponent. If your base is bigger than this number, right, like there's no way to write it as a power, that probably means you're going to need a fractional exponent. People get those confused, fractional exponents and negative exponents. If you get stuck, rewrite it using the definition, all right? That's what I call this, the definition of a logarithm, when you rewrite it as log a of x equals y, a to the y equals x. Okay, so then we also have stuff that we want to use our calculator on. And on your test, there will be questions that I just ask you to use your calculator and round to the nearest thousandths or the nearest 3 decimals. So if you just have one of my calculators, which I'll get in a minute for you if you don't have one, there's a log button. There's no base log. Do you remember what the base is of a common log? 10. Why do we call base 10 our common log? This 10 is a great number. We're base 10 number system, right? Like when we get to 9, we go to the next one. We're base 10. We have ones, tens, hundreds, thousands. That's the base 10 number system. So makes sense that our common log would be base 10 based on our number system. So when you hit on your calculator, plug in x equals 7, log 7. If there's no number there, you know that that's just log base 10 of 7. Why do we need our calculator now? Because that's not a perfect one, right? It doesn't work nicely. We could say 10 to the what equals 7. Well, that's going to be a decimal, and so that's where calculators are really handy. You should be able to know whether your answer makes sense or not, because you should be able to think about what exponent should that be to get 7. If you don't have a calculator, I'm going to give you one. Again, during a test, I will not help you use your calculator, because I'm testing that you know how to use it. So that's why I want to make sure that you have one when we do these in class, so you can ask me if you're not getting the right answers. Anybody else have a calculator? All right, they're good to go. So do these real quick. Plug these in and see what you get. And log is right underneath the second button on my calculators. And if you have a different calculator, let me know if you can't find it, and we'll look at it. 3 decimal places. So that means the 4th decimal determines whether we round up or down, right? So I think I got 0.845. And that makes sense. 10 to the first power is 10. So we should get a number less than 10 on this. This one, if we just do log of 0.42. I got negative 1.377. Did you get that? And again, how could we get 10 to something to equal a decimal? Well, it had to be a negative exponent. What happens on this one? When I do log of negative 2, what happens? Error. Domain error. Why is it an error? 10 to the what equals negative 2. Why doesn't that work? Exponential functions, right? We have that horizontal asymptote. There's no number you can plug in there that will ever give you a negative. It's why when we graph exponential functions, unless there's something added or subtracted on the outside, right? They look like that or they go the other way. They can't get you 0. So when you take the log of a negative number, it's never going to work. I can guarantee on your test I'm going to give you a question like this, only it's going to be on the no calculator part of the test, because I don't want the calculator to tell me it doesn't work. I want you to tell me it doesn't work. All right, so this is no solution, undefined, domain error, 0 with a slash through it. I don't know what you want to say. I usually say this, undefined, or you can say that. People like to do that. Empty set, that's what that means. This is other cool math language. When you just make empty brackets, like there's nothing there. That's silly. People do it. Okay. So we also have some properties of logarithms. Some of these properties you can always just figure out as you use the definition, but if you remember them, life gets a little easier as you do it. So these first 2 properties, if you take log of any base of 1, it should always be the same answer, and I'm going to kind of give you sort of a little proof out here next to it. If I rewrote this, I would get a to the what equals 1. No matter what the base is, what exponent will always give me a value of 1? 0. So log anything of 1 is 0. If you don't remember that, you just use the definition, and it works every time. Same thing with this. If I have log base a of a, whatever a happens to be, a to the what will always give me a back. And we'll talk about these properties more as we get into solving equations, but there's a few on your homework today that are this simple. They just want you to realize that exponential functions and log functions are inverses, which means if you take the log of base A to A of x, then just like the square root of x squared cancels out and you get x back, when you take the log of A to the x, those just cancel out and you just get x back, which means that's how we can solve equations that have x in the exponent. And the same thing over here, kind of looks like my A is not up there. But if you have an exponential function raised to a log power of the same base, so A of log A of x, again, they're inverses. They're just going to undo each other and you get x back. Very cool properties when we're talking about solving equations. And then this other property, this is one that I think makes sense. If log A of x equals log A of y, if they're both the same log to the same base, you agree then x has to equal y, if that's the only way you could do that. You can only do that if it's 1 log equals 1 log, which means if you have like addition or subtraction of logs, you can't just make the logs go away, which is why those properties that you learned last year are going to come back to play. Questions about that? I feel like I'm going very fast. Okay, so we talked about E last week, E being the natural exponential function. Well, then we have the inverse of that. So we also have the natural logarithmic function, and it's just a logarithm to base E. And since E is that number that we always just write as E, instead of writing log base E of x, we write ln of x. Why don't we write NL of x? I don't know. It doesn't flow as nice as ln. You can see in my print here that it's just ln print. I always make cursive ln because otherwise, if you're messy or you're not paying attention, you might think ln really says 1n, and then you're just really confused what you have going on, right? So I always make cursive L for ln of x. Same properties we can talk about here. ln is just log base E. So if we talk about ln of 1, that's like log E of 1, which is like saying E to the what equals 1. And again, whether it's ln or log base A, what exponent's going to go there? Again, there's an ln button on your calculator. Probably remember that from last year. We will definitely be using it. But we will also be doing stuff without a calculator, like questions like 8, 9, and 10 would be on a no calculator part of a test, because I don't want you just typing in your calculator. Same thing with this. If this is base E to E, what exponent's going to go there? E to the what equals E? ln and E are inverses of each other. So if you ln E, you just get x back, which is very cool. And same property, if ln of x equals ln of y, then x equals y. ln just has a special base, but it's still a logarithm, which means you also can't take the ln of a negative number. And your calculator won't let you. It'll say don't here. All right, so these last three, simplify these. The idea is if you can write it, right, this is kind of the key property, I think, on this. If you can get ln of E to a power, then your answer is just that power, right, because the ln of E cancel out. So maybe I should put these in the wrong order. Number 10 would probably be the easiest. ln of E to the third, ln of E just cancels out, and your answer would just be 3. And you can check it on your calculator if you want. If you type ln of E to the third, it gives you 3 back. Got to find that E button. It's exactly 3. So then it's not going to always be that simple. They're going to make you remember how to write exponents. So number 8, how do I write ln of 1 over E as an exponent? That would be ln of E to the... On the bottom, bring it up and makes a negative, right? So that's negative 1 power. So your answer is just negative 1. These are the types of things things you're going to see on the no calculator part of your test. And we might even have a no calculator quiz coming up sometime soon. For fun too. What about this one? What exponent is square root? 1/2, which means your answer there is just 1/2. Oh my goodness, did you get that sneeze up there? That was a lot of sneeze. And also there's parts you have to use a calculator on, right? We want to do both parts. So my last example here, before we look at some of the homework, are plug these in your calculator, round to the nearest thousandth. Three decimal places. I got negative 1.609 on that one. And what happens on number 12? You can't do it. ln of negative 1 is like saying e to the what equals negative 1. It can never happen. So this is undefined. And again, that's going to show up on a test as a no calculator problem. But I wanted to do it with the calculator so you can see that it doesn't work. And again, it comes back to the whole graph of those. Tomorrow we're going to graph logs and ln's and talk about how we can do that without a calculator, with a calculator, and if inverses. Maybe you remember what inverses look like when you graph them. And if you know what exponential graphs look like, you can figure out what logarithmic graphs will look like. The homework can be a little tricky on some of these today. So 2 through 36 even, maybe I'll do one with you real quick, and then I'll give you some time to work. If I could find my textbook, would be amazing. Maybe over here. So let's look at number 6 together real quick as you're getting your paper out. Some of them aren't so bad, but then there's some like number 6 that throw people. Sometimes it's really easy to be able to figure out like what power is that, and sometimes there's a few steps you have to take. So if I was going to rewrite this, 6 to the what equals 1 over the 5th root of 36. Maybe you just know. I'd have to do some work in here. So here's what my advice to you is. If you can't tell, the goal is, can you write this side as 6 to a power? So you want to do some work to say, how can I make this the same base as this over here? So anybody see something we could do? How could I start with rewriting that so that it could be a 6 to a power? What do you see? We definitely need to get rid of that at some point, and we can write that as a fraction, right? Like, so we could write that as, that would be the same as 36 to the 1/5 power, right? Exponents are what we want. So that's a step. What about 36? Can I do something with a 36 to make it a power of 6? So could I write this as 1 over 6 squared to the 1/5? I'm just going to write like that for a second. Do you remember what's the property with exponents when you have a power to a power? Do you remember what you do with those? Do you add, subtract, multiply, multiply? So now I have 1 over 6 to the 2/5, really the hard part. And then what's the last step? What do I do to get it up out of the fraction? Negative. So that's the same as saying 6 to the negative 2/5. There's a couple other ones like that with the fractions and the roots on there. The answer is not 6 to the negative 2/5. The answer is just the exponent. So make sure you do this work to help you. Make sure you write your answer to this is negative 2/5. Right? Because remember, the answer is the exponent that makes that true. All right, there's a couple there that are kind of difficult, but lots of these are supposed to be using the properties, using the definition, done pretty quickly. Like, not much work to show with most of these using the properties. So you probably should be able to get this done. If you have questions over test corrections, please use this time to ask me that as well. And tomorrow we'll talk about that. If you get stuck on me, ask me.